Good evening, everybody. My name's Tom, and I'd like to welcome you all to the June Recreational Astronomy Night of the Toronto Centre, the Royal Astronomical Society of Canada. Do we have anyone here who's new or here for the first time? All right, welcome. Thank you very much for joining us. This is one of two types of meetings we have. This is one of our recreational nights in which we have members of the society come up and talk about what they've done or where they've been. And in the non-summer months, we have our speaker nights in which we have a member of the astronomical community from one of the local universities come up and talk about what they've been doing lately. Tonight, we've got a fairly interesting full program. We've got the Sky This Month with Chris Vaughan, predicting risk index of asteroid collision using artificial intelligence and displaying it musically with Vikas Artash and Arushi Nath. And to end it off, a barn door tracker with alt as bass by Blake Nancaro. We'll edit that part out. Now, unfortunately, we've got some serious news, and I'm going to turn things over to Ralph, our president.
Well, good evening, everyone. You know, the president's job has a lot of perks and you know, a lot of pleasant things that go with it. But every once in a while, unfortunately, we do end up with, shall we say, unfortunate news that you know, the president ends up having to announce. So just hit the F5.
Yeah, it's okay.
Okay. Okay. So, oh, there it is. Okay. Well, I'm sorry to have to inform you that last week on June 12th, we lost one of our members, Donald Austin, who was living in Bowmanville and had in fact lived there for most of his life. Mr. Austin had joined the Toronto Centre back in 1948. He was our longest serving member of the Centre, and he was an active member right until his death last week. So the funeral was last Saturday, and we have a card up here at the front, so if any of you knew Donald Austin or would just like to pass along your pass along your condolences, please sign the card at the end of the evening. I have already contacted the family to extend our sympathies on Mr. Austin's death, but it's always nice to have a personal touch. The other sad bit of news is that earlier today I learned that one of the RASC's past presidents and honorary presidents, Dr. Ian Halliday, died recently. Dr. Halliday was a well-recognized expert around the world in the subject of meteors and meteorites. He spent his career essentially at National Research Council in Ottawa and was a very active member of the Ottawa Centre. And so we'll be sending our condolences to the Ottawa Centre on Dr. Halliday's loss. I would like to ask you to rise for a moment's silence in memory of these two gentlemen, please. Thank you very much.
Thanks, Ralph. Okay, so we're going to start things off then with Chris Vaughan and the Sky This Month. Chris?
Okay. Hi, everybody. All right, let's get started. So this presentation covers the dates that you can see there, about 4 weeks ending on July 18th. I'm going to mention a couple of things because there's some big events that happen just past my window, so I don't see any harm in giving you an early warning or an early heads up on those. I'm talking about Mars, of course, and I expect that next month's presenter will have lots more to say about that, but let's get started. So what I'm going to do tonight is cover a little bit about space exploration news, this month in history, just remembering back a little bit, and then get into observing, and I'm going to present all my times in Eastern Daylight Times converted from Universal Time -4 hours. And we're going to look at the sun and moon, planet doings, comets, asteroids, some satellite information, one occultation, and some suggested early summer targets for you to look at. And I'll be posting all the content online at riscto.ca tonight or tomorrow morning. All right, so in case you're feeling drowsy and you want to nod off after the slide, then I'll give you some of the highlights to start off with, and then we'll flesh them out as we go. So as I said, this is the summer of Mars. The summer of Mars has officially begun because Mars is now rising before midnight. I consider it an evening planet finally, and it's going to be making its move over the next few weeks, getting ready for the big show next month. Summer Milky Way season is here, of course. June 21st brings us the solstice. Good news, nights start getting longer again shortly after that, so that's good for us. I've got a couple of comets to mention. They're pretty dim now, but they are trending up, brightening up, so I'll give you some idea of where they're moving, what part of the sky they're passing through, and I'll point out a couple of photo opportunities you might want to track those down. We've got Saturn in opposition on the 27th with the full mini-moon. It's the smallest full moon of the year. And on July 10th, the moon is going to slide past Aldebaran, and if you want to do a little bit of driving, you might even see the grazing occultation of that one. And on July 14th, there's an asteroidal occultation west, sort of London area, west of Toronto. And finally, another nice photo op is on the 15th of July, the moon sitting between Venus and Regulus. So a few rocket launches of note. The first one's the kind of more interesting one. This is this radical or audacious startup from New Zealand that are launching rockets from Rocket Lab. And I think they're taking a page from Elon Musk and using funny names for their missions. So this is called It's Business Time. And they're launching some CubeSats and some remote sensing sats. And then we have a launch from China of a communications remote sensing satellite, and then a couple of missions delivering cargo to the International Space Station. One is a Falcon 9, and the other is a Soyuz rocket in early July. Just a bit of an update on some of the missions that are going on right now in the solar system. We've got OSIRIS-REx is still chugging away, heading towards its rendezvous with Bennu. That will be a sample return mission eventually. And we've got New Horizons. If you're a New Horizons fan, you're getting excited already because we're only 6 months out from its next flyby of that little Kuiper Belt object, 2014 MU69. I forget, it has a new name, I forget what it is. But then we've got Hayabusa 2 is about to rendezvous with the asteroid Ryugu. I'll have a little bit more to say on that in a minute. And again, another thing I'm going to talk about more in a minute is this Qiaqiao, or Queqiao, a spacecraft from China that's setting up China's upcoming landing on the far side of the moon. Just some eye candy for you to wet your whistle. Juno spacecraft has been orbiting Jupiter now for some time, and it's completed 12 perijove or diving passes of the planet, close-up views of the planet. And Sean Duran has put together the images into these cool mosaics. So this is he's done 12 of them. This is the sort of first set, and then there's a second batch in the second set. And these are megapixel, gigapixel size images. So if you want to, I've got the link to it in my notes, and if you want to follow that link, you can see these in all beautiful detail that they come in. Well, that's kind of fun. Okay, so the Hayabusa 2 spacecraft, it's a Japanese spacecraft. It's on its way to a rendezvous with this asteroid named Ryugu, and it's an ion powered, so it's putting along through the solar system on its way. It's approaching the asteroid at about 0.83 meters per second, and will arrive over the next couple of weeks. And initially, it's going to take a 20-kilometer survey orbit as it maps the asteroid in detail, determines its gravitational field, and gets ready for the point where it comes and does a touch and go and grabs a sample and then returns that to Earth in 2020. It also has a couple of small probes. I think 1 or 2 of them are going to land on the asteroid or try to, and then another one is going to try to impact and dig a little crater in the asteroid for people to analyze what comes out. The gravity is so light around the crater that you can't, properly tether a spacecraft to it. So these little landers, heard that one of them is going to move about the asteroid by just tossing a weight inside of itself, which kicks itself into the air, and then it'll tumble and land somewhere else, and so it'll be able to sort of move around a little bit. So that's something to watch for. And this is a little graphic animation of 52 images put together to show the Ryugu asteroids in 3 dimensions as it's being surveyed. It's a little bit jerky, but you can get a sort of a sense of it. Look, it reminds me of a Dungeons and Dragons die, actually. So there's that. Here's the Queqiao Chinese spacecraft. So the first spacecraft has gone to orbit around the lunar L2, or Lagrange 2 point, which is a gravitationally stable point on the far side of the moon. So the spacecraft can orbit that L2 point and stand ready to receive the second spacecraft, the Chang'e lander, that's just the green line, that's going to land on the far side of the moon and do a little roving about. So that'll be exciting for China and see what comes of that. They've also deployed a couple of small remote sensing satellites called Longjiang. There were 2 of them. One of them failed to reach lunar orbit. The other one's gone into lunar orbit, and that's an image produced by that spacecraft. So it's beautiful pictures. All right, so this month in history, we can celebrate on June 26th the birthday of Charles Messier, and French astronomer, published his eponymous, famous Messier catalog of annoying fuzzy objects that aren't comets. And that sketch on the right is one of his sketches of the Orion Nebula, taken through the eyepiece. Then on July 7th, 1746, we've got Giuseppe Piazzi, who discovered the asteroid Ceres. And on July 7th, 1907, the birth of Robert Heinlein, the American Dean of Science Fiction. That's how I got my start in science fiction. I'm sure some others in here have as well. On July 10th, we've got the birthday of Alvin G. Clark. He was the son in the Clark family, and he himself was the first observer of the Sirius B white dwarf star. I think he had good equipment, though. I think he had an advantage there. July 13th, we've got the birthday of Mary Lee Shane. She was an American astronomer who specialized in the spectra of the interstellar medium. All right, so this month in history, on June 30th, 1908, we have the mysterious Great Tunguska air blast in Siberia around 7 a.m. local time. But scientists weren't able to visit the site and see what happened for quite a number of years later, not until 1921. And then this photograph is taken in 1929. Even farther after that, showing all the trees knocked down by the air blast. On July 1st, 1917, the 100-inch Hooker telescope mirror arrives at Mount Wilson. So when the David Dunlap Observatory opened in 1935, this was the only telescope in the world that was bigger. So here's a couple of pictures. There's the mirror cell being transported through the hole in the floor. If you look down here, you can see there's a hatch in the floor. So they move away that hatch, and they're able to disassemble the mirror cell and bring it down for reilluminizing. So we do something similar to that at the David Dunlap Observatory. July 4th, 1054, Chinese astronomers record the supernova that then later became Messier 1, or the Crab Nebula. And on July 4th as well, in 1997, we have the NASA Pathfinder Sojourner mission landing on Mars. Then on the 6th of July, we've got Newton publishing his Principia Mathematica that contains his 3 laws of motion. And something crashed in Roswell, New Mexico on July 7th, 1959. Then in 1994, we have the comet Shoemaker-Levy 9 fragmenting, and all the fragments plunging into Jupiter at high rate of speed, 216,000 kilometers per hour, and creating all of those dark scars temporarily on Jupiter's face. And on July 16th, we have the Apollo 11 launch in 1969. All right, getting into observing now. This is a nice picture of the Summer Triangle region taken by Michael Watson. You can see we've got Vega and Lyra up here, and then we've got Deneb down near the North American Nebula, and then we've got Altair down here, and the Milky Way passing through that region of the sky. Rascals are wanted to map light pollution wherever they happen to be. So the Globe at Night program is designed to turn us all into citizen scientists and help us to track and monitor light pollution as it increases throughout the world. And during the period that they indicate, you're to go off and observe the sky in your local area. And what they do is they give you a constellation to look at and ask you to see how dim of the stars can you detect from your location, and then submit your entry and log that in. So in July and August this summer, it's the constellation of Hercules, and you can see that I'm used to seeing Hercules in a sort of a fuzzy sky, so I'm sort of in the middle at magnitude 3 and 4. By the time it gets into really good sky or really poor sky, I can't find it anymore. But they've got all these charts that you can download. And to find the website, you just go to globeatnight.org, and they've got the other campaign dates listed there. All right, so what's the sun up to? Well, first of all, we've got the solstice on the 21st of June in the morning at 6:07 a.m., and then we have Earth's aphelion, or Earth's farthest distance from the sun, occurring on Friday, July 6th at 1 p.m. So a lot of people have the misconception that our weather varies because of the distance from the sun, and in fact, we're actually closest to the sun in the winter in North America, and we're farthest in the summer. So it's a different factor. Astronomical twilight is important to all of us astronomers that want to see the dim objects or do astroimaging. And essentially what we're looking for is the sky to become as black or as dark as it gets once the sun goes down. And astronomical twilight is defined as the sun being at more than 18, or ends when the sun is at 18 degrees or lower below the horizon. So at that point, the sky should become as dark as it will be. And on June 20th, astronomical twilight will end at 11:25 tonight. And it won't start again until 3 in the morning or 3:13 in the morning. That only gives us only 3 3/4 hours of imaging time, which is not very nice, but hey. But a month from now, in 4 weeks, we get almost another hour of imaging time, 4 hours, 39 minutes. So things looking up. Right. And there you can see the diagram for the distribution of daytime and nighttime throughout the year. Here we are on the solstice. So you can see that it'll take another couple weeks before this curve starts to head back up and the nighttime starts to increase again. But it's coming. So this is cool. This is the picture that Ian Wilband took of first light through RASC's new 16-inch telescope in the Jeff Brown Observatory at the CAO. Yeah. So a bit more on that at the end. But as to what the moon's up to, so we have apogee and perigee. Apogee on the 29th, perigee on the 13th, and that's that perigee is occurring about 5 hours after the new moon. So that's going to give large tides. And then we've got the moon phases here, and especially interesting, of course, is the new moon on July 12th. That'll also trigger a partial solar eclipse that is visible only in the Antarctica, basically. So I don't recommend setting a... And it's partial, so there you go. All right, so where are the planets these days? So we've got, this is the evening sky. So we've got the sun heading down in the west in the evening sky. We've got the inner planets Mercury and Venus sort of following it down within hours of that. We do have the dwarf planet, formerly asteroid, now dwarf planet Ceres, sitting in Leo, not far from Venus, but it's really kind of getting into limited observing time once Leo gets low in the sky in the west. Then in the middle of the sky, we've got, let's see where we've got Jupiter. Sorry, I went back one. There we go. Evening planets, yeah. And we've got Jupiter sort of in the middle, in the southern sky in the evening time. We've got Saturn sort of just above the southeastern horizon in the evening. And here's Vesta sitting just inside the Milky Way in Ophiuchus. And then as we get into the middle of the night, we start to lose Jupiter a little bit. So, you know, do your observing of Jupiter now while you can, because we've only got a couple more months of decent views of it. Then we've got Saturn in the middle of the night in the south. Mars comes up and sits in the middle of the night. And here's what's disappointing is that the summertime ecliptic is so low that all these great planets aren't going to get very high in our sky. But if you do any traveling and you want to go south, you can make them as high as you like, the farther south you go. Then if you're interested in ice giant planets, we've got Neptune available in the pre-dawn for a few hours. But if you really want to see it, your best bet is to go later in the pre-dawn sky, where we can then get Neptune in Aquarius, and then Uranus in Pisces, and we've got the other asteroid Juno sitting near Uranus in that part of the sky. So what are the planets up to in a little more detail? We've got Mercury doing a so-so apparition for the next 4 weeks, with the best time to see it roughly between 9:30 and 10 p.m. Mercury's disk is growing while it's waning in phase as it approaches Earth, and its brightness is basically at a peak now, so it's going to fade from here. So try to see it sooner than later. On July 3rd to 5th, it's going to pass just through the southern part of the Beehive cluster in Cancer. So you may or may not have a problem with twilight, but if you use binoculars and wait till the sky gets dark and they get a little lower, you'll probably be able to pick some of the Beehive stars out of that. Venus is sitting brilliantly shining at magnitude -4.1 in the western evening sky. Tonight, it's near the Beehive also, but it is now starting to do its descent. So it's setting about 11:30 now, and that'll be about 10:30 in 4 weeks from now. And its disk diameter is going to continue to increase in diameter by about 28%, but its waning gibbous phase will remain about the same waning gibbous shape for the next 4 weeks or so. And look on the 15th for the moon sitting between Venus and Regulus. That might make a nice wide field photo op. So the summer of Mars is here. Mars is now rising about 11:30 p.m. 4 weeks from now, that'll be a little bit before 10 p.m. So it's getting better and better. It's going to continue to brighten all the while. It's about magnitude -1.8 now, but it's going to keep going. By the 18th of July, it'll be -2.6 and not finished yet. And then its disk size is going to increase, as shown here, from 19 arc seconds on the left to 23.7 arc seconds on the right by the time of our next meeting. But it's not finished either. It's going to keep growing after that. So opposition actually officially occurs on July 27th. It's going to have a full moon sitting right beside it. And that full moon is going to be in total lunar eclipse for parts of the world in Africa, Middle East, India, and Western Australia. At opposition, Mars will be only 3.2 light minutes away. So that's pretty fast turnaround time for all those Mars missions that we're communicating with. It'll reach magnitude -2.8. Its apparent disk size will grow to 24.3 arc seconds. And unfortunately, it's going to sit there well below the ecliptic, quite low in the sky. So we do have time to wait till after midnight when it rises a little bit higher to see it decently. It's going to sort of cause a challenge for star parties and public events where it really won't be at its best at the time most people want to go to bed. Yeah. But, you know, once we get into August, it'll actually be up higher earlier in the evening, so it won't be quite as close, but it'll still be a good time to look at it. Now, its actual closest date to Earth doesn't occur for a few days afterwards. That's on July 31st, and it won't be as close again until 2035. So it's definitely worth taking your look at Mars this year. Jupiter's hanging out in the western half of the sky right now in central Libra. It's moving retrograde westward, kind of away from the star Zubino-Ganubi, which is down here, bright star, double star in Libra. And if you watch Jupiter over the next little while, it'll continue to draw away from the star until the July 10th, and then it's going to stand still and then start reversing and heading east again. So you'll be able to watch the loop happening if you monitor the separation between the star and the planet. So Jupiter's setting about 3 a.m. now, and it'll be only after 1 a.m. in about 4 weeks. And look for the moon sitting nearby on June 23rd. And here's another shot that Ian sent me. So this is an Io transit and Great Red Spot pairing that happened just a couple of nights ago. And Ian took this through his job at the CAO. So that's cool. And speaking of that, so in my handout, I've listed 7 single moon shadow transit events that are happening over the next 4 weeks. And actually, there's one happening tonight. So the one that happens tonight is also got the Great Red Spot visible at the same time. That'll run between about 11 p.m. and 1:13 a.m. So after your Granite Club, you can go off and look for Jupiter. And then the picture I'm showing you here is an example from Friday, June 22nd, where Io went at shadow will transit starting a little bit earlier. I think this is pictures taken mid-transit at 11:45 p.m., so you could probably start looking an hour before that. And again, the red spot will be there. Quite a few of them have red spot coinciding with the transits in the list that I put together. So Saturn is sitting beside the Milky Way, just above the teapot of Sagittarius. It's moving retrograde right now in the southern sky, but it's visible basically all night. And that's because a week from now, it reaches opposition. So at opposition, it'll peak at about magnitude 0, and its planet's disk will be a maximum size for us for the year at 18.4 arcseconds, and the rings extend that to 42 arcseconds across. And look for the full moon again. So we've got Mars having a full moon at opposition and Saturn having a full moon at opposition. Funny coincidence this year on the 27th. Uranus, if you're into ice giants, it's at magnitude 5.9. So it's binocular target for sure. It's in Western Aries, right near Pisces, in the eastern pre-dawn sky. And you can look for that basically between about 2:30 a.m. and dawn. It'll rise a little bit earlier, about an hour earlier than that in 4 weeks. And don't forget about Juno sitting below it. So I've got finder charts for that. And finally, Neptune, magnitude 7.8, sitting in Aquarius. And Neptune has actually given us a bit of a gift for how to find it, because you can actually just look for this naked eye star, Hydor, and go 4.5 degrees east, and look for this naked eye star, Psi, and just go 3 degrees up. And it makes kind of a right angle triangle with those two stars. And so you should be able to find it. And asteroid Vesta. So asteroid Vesta reached peak visibility last night. It reached opposition yesterday. So it's definitely binocular target at magnitude 5.3. And if you can get to a dark, dark sky, maybe you could even see it naked eye. I don't know. It's in Sagittarius, moving retrograde until the end of the month, and then it'll move into Ophiuchus next door. I like to note the minor planet discoveries. It just blows my mind how many minor planets are out there. So this is an old diagram that's been greatly superseded since then. But right now, so far this year, we've got another 838 near-Earth objects. So those are the ones that are the red dots that orbit near Earth. And they're discovered at a rate of almost 150 a month. Then just plain old minor planets, the green ones that are anywhere in the solar system. There's already another 3,500 of those this year. And those are coming in at about 630 per month. And so far, 20 new comets this year. And that's a lot. Mostly it's robotic observations, but so far there have been 8.2 million observations year to date since January 1st. So here are the two comets I was talking about. The first one is Comet 21P Giacobini-Zinner. And you can see from there's an image that was taken on May 21st, a little tiny smudge there. You can see, not too impressive yet. But here's the predicted light curve. So now we're sitting just in here somewhere. So we're around magnitude 12. We've got a ways to go, and it should peak somewhere between magnitude 7 and 8 over the next couple of months. So by September, it's predicted to increase in brightness to magnitude 8. Right now, it's in the northeastern sky. It gets higher and higher through the night, so it sort of culminates just about the time the sun's going to come up and start getting the skylight again. So you want to sort of look a little earlier than that. But there are a bunch of neat little milestones. So right now, tonight, it's sitting just on the edge of the North American Nebula. So if you wanted to do sort of a long exposure photograph in this patch of sky, you might pick up the comet sitting there nearby. But as you go on, it'll get brighter and brighter. You've got on the 28th, it's going to pass by Messier 39. This is the track. Each of these little circles is a day. Then by the time we get to July 10th, it's going to pass below the Elephant Trunk Nebula and the Garnet Star region of Cepheus. And then on the 20th of July, it's going to sit very, very close to this little planetary nebula, NGC 7354, I think it is. Yeah. Here's the other comet, Comet C2017 S3 Pan-STARRS. And again, it's another little smudge in this photo. But here's the light curve. And this one's going to peak, predicted to peak up at magnitude 4, which is definitely binocular range. So we're really excited about that one. And right now, it's sitting just sort of between the double cluster and the Heart and Soul Nebula up here near Cassiopeia. And again, it's in the northern sky, culminating a bit before dawn. You can look for it sort of passing between these two naked-eyed stars, CS Camelopardalis, and this one, I'm not sure the designation, on the 5th, and then on from there. So it's something you want to sort of keep tabs on. Meteor showers, nothing really happening right now, but of course, my window includes the start of the Perseid meteor shower. So it officially kicks off on July 13th, and the cool thing about this is it's going to peak overnight on Saturday and Sunday. It's supposed to be a broad peak this year, encompassing both nights. And what's cool is that it's a new moon weekend. New moon weekend, so it should be perfect. I've got my reservation at CAO. Well, I'm in. All right, so there you go. In terms of the ISS, there are no passes happening right now over the GTA, but morning passes begin again on July 3rd, mostly between 1 and 5 a.m. And then there's some evening passes that'll start on the 20th of July. And some of the better passes are listed here, and again, they're in the handout if you want to download it off the website. Radiant flares. Radiant flares are mostly happening after 11 p.m. in the evening or from about 2:30 to 5 a.m. in the morning. And to find out when they're happening, you can log into heavensabove.com and input your viewing location, and it'll generate a table of all the iridium flares for your viewing site. Or you can grab one of the good smartphone apps that list them. I also tabulate them in my weekly Skylight blog. If you want to see that, you can subscribe to it, or you can look for it on Tumblr under AstroGeoGuy. And get them while you can, because they're already deorbiting these satellites and replacing them with ones that aren't so reflective. So the era of iridium flares is going to come to an end soon. Here's the asteroidal occultation I mentioned at the beginning. It's a bit out of town for us. It's sort of centered over London area. And while the asteroid, magnitude 10.7, and the star, magnitude 11.4, are pretty easy, not too dim, the magnitude dip is only a half a magnitude, 0.47 magnitudes for 6.2 seconds. But it's a nice time in the evening. It's 11:30 p.m. in the evening, local time. And it's a nice altitude, 41 degrees above the horizon. And the confidence interval are the blue lines. So if you're in between the two blue lines, you stand a good chance of seeing the occultation happen if the weather's good. Is that? Lunar occultation. So as I mentioned, on July 10th, the moon, the old crescent moon, is going to sort of skim past Aldebaran in the morning pre-dawn sky. And the farther north you are, the more closer you get to actually seeing an occultation. So I calculated that if you went up to around Wawa, you might start getting the grazing occultation, where the star just sort of skims through the peaks and valleys on the southern edge of the moon. But folks in well north of North America, Greenland, northern Russia, they'll see the actual occultation of the moon passing in front of Aldebaran. Constellations on the sky in early July. So we like to look at objects when they're on the meridian because they're the highest in the sky they get. And that means we're seeing them through the least amount of Earth's distorting atmosphere. And so if you're chasing objects in any of these constellations, you want to look for them around 11 o'clock. That's when they cross the meridian. If you're looking more for the Scorpius, Scutum, sort of the central Milky Way, anything in the Milky Way and those objects, and up through Cygnus and Lyra, they're crossing the meridian at about 1 a.m. Towards the beginning of July. And finally, at 3 a.m., if you were going to want to stay up a little bit later, you can start picking up parts of Capricornus and over to Aquarius and Aquilus and Delphina and Vulpecula and things like that. A couple of suggested things that you might want to take a look for next time you're out. The veil. If you have a large aperture telescope and you have access to an O3 filter, an oxygen 3 filter, look at the Veil Nebula. It's spectacular. It's amazing. And hopefully when we get up to the CAO this summer, we'll have some of our big aperture telescopes working, and you'll be able to get a good look at that. Also, the Eagle Nebula down here near Scutum is another one that's great at low power and with an O3 filter to bring it out of the background. And then take a look at Lyra. Most of the major stars in Lyra are double stars, including pretty much all four corners of the box. And we've also got the double-double in Lyra as well. And sort of towards the bottom center of the parallelogram, there's a nice little star called HR 7140, and it actually reminds me a lot of Albireo. So you sort of have Albireo, the real Albireo sitting here, and then kind of a false Albireo sitting not far away. It's kind of a cool thing. And then tour the Milky Way while you're out there, and hey, go after the globular clusters in Ophiuchus. There's probably about 15 of them. How many can you find? So it's a great little challenge. Then if you're doing a star party, I like to list some suggested objects. You know, we can show people a lot of the big asterisms like the Dipper, the Keystone in Hercules, the shape of Scorpius and the Teapot in Sagittarius, as well as the Summer Triangle. Some of the major globular clusters include Messier 13 and Messier 92, and a few others there. Some are blobs, so other than the Eagle and the Veil, we've got the Lagoon and Trifid nebulas toward the Milky Way part of the sky. The North American Nebula up at Cygnus, and the Heart and Soul up in Cassiopeia. And then some of the little knobs, the little nebulas, the planetary nebulas, including the Ring Nebula in Lyra, the Dumbbell in Vulpecula, and there's the Turtle Nebula in Hercules, and the Cat's Eye in Draco. Open star clusters include Melotte 111 in Coma. Wild Duck is always really good, and there's the Graph's cluster in Serpens, and the Coat Hanger, which is great in binoculars. Double stars include Regulus and Algieba, Iota Cancri, Corcoroli, I think it was mentioned last month, Porrima and Izar. And then, you know, it's nice to teach people all the names of the bright stars they can see in the summer sky. So that's it. I hope you come to CAO and Baby Village, and this is little taste. So this is the new 16-inch RC scope in the GBO. Nice picture of the moon through that. And just if that doesn't sell you, then we've got the new imaging observatory that's sitting just off the GBO. But thanks to all the great people that helped put that together. And that's it for me. Thanks a lot. No, we're good? Excellent, good.
Yay.
Thank you very much, Chris. All right, so next up we have the Nath family. We'll be talking about asteroid predictions and putting it to music.
My name's Artash. And my name's Arushi. Good evening, everybody. I hope you're enjoying this hot summer days now. So, we've been working on many projects in the last few months. One of our most recent projects is SpaceRex. So, SpaceRex is all about asteroids and predicting their collision risk index with the Earth. We named it SpaceRex because 66 million years ago, dinosaurs got extinct because of the huge asteroid that collided with the Earth and caused dust clouds all around and killed the dinosaurs. And we believe it's because they didn't have a space monitoring system. We humans, now we have so many satellites inside the sky, we shouldn't have the same thing happen to us. So, there are many asteroids in our solar system, and lots of them close to the Earth are classified as near-Earth objects. So near-Earth objects are asteroids or comets or any other objects like that pass in a range of 1.3 astronomical units from the Sun. So among all these asteroids, not all of them might hit the Earth. So the range of asteroids that have a chance of actually colliding with the Earth is only 0.05 astronomical units from the Earth. So a simpler way of saying this would be in lunar distances. So it's equivalent to around 20 lunar distances from the Earth. So any asteroid in between 20 lunar distances of the Earth has a chance of colliding with the Earth. So there are not many comets, not as many as asteroids, that come near our solar system. We only found around 107 comets that come close to the Earth, and more than around 2,000 asteroids. So our SpaceRex, as I said, is about predicting collision risk index of the asteroid with the Earth. This can be a very difficult task because the parameters of the asteroids vary a lot. The three main parameters that you could describe an asteroid with is its orbital period. So all of the asteroids spin along the Sun in motion. So that can change a lot because the path of the asteroid might change. And as it comes close to the Sun, it might melt a bit, evaporate a bit, and its mass will change, and the orbit will change a little too. The next parameter is its diameter. So the size of an asteroid varies a lot, between up to only 100 meters to over a few hundred kilometers. The final parameter that you could describe an asteroid with is its velocity. So the speed of the asteroid, which could change as it gets closer to the Sun because of its gravity and the change. So this can be a very complex task. So we have decided to try to employ AI to solve this task. So now I'm going to get Arushi to give a short description of artificial intelligence.
So now I'm going to tell you a bit more about AI. So let's see if the AI can recognize if an image of a cow and say if it's a cow or not. Well, there's three main parts. The first one is the input, then it is the output, and then it is the hidden layer. The input is when we are going to give lots of images to the AI. The output is when the AI is going to say if the image is a cow or not. And the hidden layers is the magic behind. So now, let's say we take 1,000 images of a cow of different sizes, colors, and we feed it to the AI. Then, we're going to give the AI around 300 images, and then the AI is going to say to each image if it's an AI, if it's a cow or not. And if it says, for example, something is a cow but it's not, then we're going to say add images. Yeah.
Backwards.
So this is an example of an artificial intelligence algorithm, a neural network, which is composed of many neurons, just like we have inside our head. So there's the input layer that she was talking about, where you would provide the images of cows, and these are the two hidden layers, where the magic is actually going to happen, and then the output layer, where it's going to tell if it's a cow or not. So I'm going to now explain you the actual thing that happens.
It's not going left and right. It's not going left and right.
So we're going to do exactly the same thing that she did, except for asteroids this time. So we're going to use the same parameters that I told you, the asteroid's orbital period, the asteroid's velocity and diameter, and we're going to use these as the inputs of our artificial intelligence. Our output is actually going to be the danger risk index. So here is the data that we got for a couple of asteroids. So we got it from the Century NASA database because NASA gives like a lot of information about asteroids on its website. So we took a couple of 100 images from NASA, and then we used those and asteroid parameters actually, asteroids, their names, and the parameters, predefined parameters. So we already know the orbital period, the diameter, etc. of the asteroid, and we also know the danger risk index. Now, the danger risk index here is actually called the Palmyra index. So the Palmyra index is a way of measuring the risk of the asteroid colliding with the Earth. So then we ran it through our artificial intelligence. So what's going to happen inside the artificial intelligence? Well, first we have to train our artificial intelligence so it can actually predict the Palmyra index for all of these asteroids. To do that, we need a training database. The training database, as I told you, is all the asteroids from the NASA Century with all their parameters and the danger risk index. For that, we train them through our neural network. So it keeps teaching the neurons how to identify the Palmyra index of the asteroids based on its parameters. It adjusts weights for each of the parameters of the asteroids and keeps adjusting those weights many 100,000 times, thousands of times, until it actually can get an accurate prediction of all of the asteroids. So the next step is the training database. The training database is actually used to see if our neural network has been trained enough to be able to predict the Palmyra index for all of the asteroids. So we fed these values to the neural network, but this time we didn't actually give them the risk index, and we tried to see how well our artificial intelligence can predict the danger index of each of the asteroids. So then we saw if it was really accurate. So is it accurate enough so we can actually test it on an unknown database yet? So if it's not, we have to retrain it with more data until it becomes good enough to be able to test it on a completely new database without a danger risk index. So the final step after we tested it is actually applying the neural network to find the danger risk index of other asteroids which the Palmyra index has not been provided with. So these are some of the results we got here of the Palmyra index from our neural network. And here are some of the asteroids with their parameters. So you can see the different Palmyra indexes. But what is a Palmyra index? So a Palmyra index is a number that would represent its collision risk with the Earth. So if the number is below -2, it means it doesn't merit any attention because it's probably not going to crash with the Earth. If between -2 and 0, it actually merits careful monitoring because there's a chance it could collide with the Earth. And if it's higher than 0, it means it could actually be a potential danger to the Earth. These are some more data points we got for these objects. So you can see here the object is listed, the velocity, the magnitude, the estimated diameter, and then here is our predicted Palmyra index for those asteroids. So I'm going to show you the top 3 asteroids with the most Palmyra index, so the highest Palmyra index. So there's the 1950 DA, which is a Palmyra index of -1.42. There's the asteroid Bennu, which has a Palmyra index of -2.3. So as Chris said in his presentation, the OSIRIS-REx will be going to Bennu to mine it with samples and return back to the Earth. And the reason they sent it to Bennu, one of the reasons were it's because of its high risk index, it might collide with the Earth in the future. So if we get that information about the asteroid, it might be easier to deflect the asteroid from the Earth if it goes too close to the Earth. And finally is the 2009 FD, which is another asteroid with a high Palmyra index. You can notice that none of these Palmyra index is actually larger than 0, by the way. So they're all between -2 and -1. So this is just a quick flowchart to review what I've told you. So here is the Near Earth Object Database, which I've used to train our artificial intelligence to predict Palmyra indexes of the Century Earth Impact Monitoring System. So that goes into our artificial intelligence. And then this is actually a future model of what could happen if we were actually, like, let's say, on a space settlement, and we wanted to use the artificial intelligence to actually predict if an asteroid is going to hit the space settlement, whether we should deflect it or mine it. So if the Palmyra index is from -1 to -4, it's not actually going to be a danger to the space settlement. So we can just, if it's high in metal, we can mine it because it'll profit the space settlement. And if it's more than 0, we'll have to deflect it from the space settlement survey. So here's a little peek in the neural network code that I wrote in Python, which is the code I trained to predict the Palmyra index using NumPy and Python. And then we actually wanted to display this data visually.
Yeah. So what I did is I did some coding. So basically, so in between some numbers, I made it put a specific note so that we could convert the numbers into notes.
Basically, what we did is we wanted to represent the decision making of the asteroids coming and how that the space settlement would deflect it. So we made a little model right here, So each of these aligned strips represent one orbit of the astral critique around the space element here. And yeah, we're just going to give you a little demo of it. So that's that asteroid entering the orbit around the space element. Then it's going closer to the space element. We've detected it's not actually going to be a potential danger to the space element. So we put it in this orbit here, and we're keeping it here so we can later come and mine the astral cloud. Here's another astral cloud. This seems to be coming pretty quickly to the space element. So it actually might be a dangerous. It's coming into the center. So quickly we have to deflect the asteroid before it actually causes danger to the space element. And we've ejected it back into the outermost orbit. So yeah, that was just a quick demo of what would happen to the space element. So that brings us to a conclusion. So what is the future for our project? So later on, we believe there will be many space settlements, many different space settlements, lots of asteroids. But for this, we will need this project to be able to detect asteroids, to be able to predict them with their danger risk index and deflect them in time. So this project is called the Real-Time Near-Earth Object Detection with Intelligent Neural Networks, RUN. So with this, we hope to use better neural networks, have live data and predictions, and have even more outputs to suggest different deflection methods for the asteroid. And use more futuristic technologies to improve this project. Thank you.
Any questions? Any questions? Can we bring the house up? Can we bring the house lights?
No, sorry. We can't get those.
Oh, okay. That didn't.
How many variables did you have in the input layer of your neural network? Should I repeat that? How many variables were in the input layer of your neural network?
Well, in the input layer of the neural network, there was those 3 parameters I talked about, the main parameters of the asteroid. So the orbital period, the velocity, and the diameter of the asteroid, which we entered. Those were the only 3 inputs we entered into our neural network to get out the Palmyra index.
And one more question. So which library did you use for your neural networks? Because you said you were extending it to use TensorFlow.
Yes. So I didn't actually know TensorFlow at the time that we were making the project a few months ago. So I had to actually manually create my neural network. So using the activation functions for the neural network and manually created, as I said in my code. But now we've started learning TensorFlow, so it'll make things much easier and more accurate.
Wow, great.
When you were doing your training of the model, what criteria did you use to establish that your model was good enough to try? Like you were using a criteria of the predicted risk index with the actual one. So
Yep.
how close did it have to be in order for you to move to the next step with the training model?
Well, good question. So, as I said about the testing databases, when we tested it to see how accurate it was, we gave it quite a wide range, so like even up to like 1 or 2, because we were only using a 1 neuron neural network that time, because it'll be really difficult to manually create a proper neural network with actual layers inside it. So, yeah.
Hi, I don't have a question, but I just wanted to say that your data analysis and programming skills in Python are better than mine. And I'm doing my master's degree. So that's That's very incredible. Good for you.
Anybody else? No? All right. Well, thanks, guys. Yeah. And next up, ladies and gentlemen, we have Blake Sanhero showing off his new Sky Tracker.
Hang on. I'm just gonna say. Work. Hey. Yeah. Good evening. How's everybody doing? Good. My name is Blake Nancaro, and I wanted to talk to you about my BDT plus ABB. That's the barn door tracker with Alt-Az, or adjustable base. I was always interested in these, knew about these from a long time ago, but never really felt compelled to do something about it. But I'll talk about who convinced me to do it, whose fault it was, and why I decided to proceed with this and so on. In case you're not familiar with it, a barn door tracker, this is not mine, obviously this image here, but that's how simply you could make one. Maybe you've got all those parts at home, so you wouldn't have to spend anything, just rummage through the bins and find a hinge and make a little dial or a wheel that's calibrated. You can see that this is manually controlled. This is what people did, though, in the early days with simple home-built barn door trackers. They manually adjusted that dial at a prescribed rate, and that opens up the hinge at the right rate. And ultimately, what you're trying to do is compensate for the rotation of the Earth. You may know that if you put a camera on a fixed tripod and aim up at the sky after 15 seconds, 30 seconds or so, you're going to see that your stars are becoming stretched, little curved arcs. It depends on your focal length and other factors, your lens and so on. But in general, when you start doing long exposures, 30 seconds, 60 seconds, a couple of minutes, you're not going to have round stars anymore. So a barn door tracker or some sort of tracking device is needed if you want to do wide field photography of some kind. This is maybe what a lot of people think of as the classic barn door tracker. Two pieces of wood, you can see there's a little hinge between them. There's a screw here or a bolt that is turned once again at a prescribed rate, and it makes those two boards move apart. You see the little string here as a catch so it doesn't flop open. And I think this is very clever here. I'm pretty sure that's just the body of a pen, an old pen that's hollow, plastic tube, and somebody's glued it to the hinge to do the polar alignment. So again, you could build one of these out of spare parts, really simple, easy to do. I wasn't really interested in a design like this though, because you have to manually touch this unit, and part of what you're trying to do with these two barn door plates is track the stars smoothly, move your camera smoothly. So I didn't want to build something that would require any manual intervention. So I was interested in a motorized solution if I was going to do this. But I was really sitting on the fence. I didn't know whether I should make one of these or not. These sometimes are called Hague mounts or Scotch mounts. And you're trying to, once again, you're trying to compensate for the diurnal rotation of the Earth. It's not the sky moving, it's the Earth turning underneath the sky, of course. Another reason that I wasn't really super keen initially at doing something like this is because you can do piggyback photography. I'd already done that a little bit. You can put your camera on top of your telescope, which is on an equatorial mount, and then you can do wide field photography that way. I'd done that with a couple of different telescopes. And this whole field is getting very interesting. It's a really hot sort of segment within our hobby, people doing photography like this. So there's lots of equipment that I had opportunities to try out. I was able to borrow some of these types of devices. This is one of the first ones that I had seen. One of our members, Steve McKinney, brought his AstroTrack up to the Carr Astronomical Observatory, the CAO. So I saw this in action. It's a swing arm design. They have a limited range of motion. It depends how long that screw or rod is in there. But that's one design. And you can see there's a camera with a fairly long lens on it and a counterweight. So this is one type of design that you can get. Some of you may have seen these. Some people may have this. The Vixen Polaria is quite possibly the smallest tracker unit. You can see that's about the size of a point-and-shoot camera, or a small, maybe a Micro Four Thirds camera. And that wheel turns, once again, at a 24-hour rate, at the sidereal rate, so very compact. And I don't know if you can see it well in this photo, but there's a little sight hole like the old rangefinder cameras to do your polar alignment. So that's another type of design. This is perhaps the most popular one. Who's got one of these? There's a couple of people maybe that have the Star Adventurer. The Toronto Centre owns one of these. It's up at the CAO. When you're visiting the CAO, you can book time on that. You can use that. You can try it out. I've used it a couple of times to get familiar with it. It's really a mini baby equatorial mount. And you can see it's got a polar scope in it. So when I used it, I found it pretty straightforward. I'm familiar with an equatorial mount, how to polar alignment. So pretty easy to use. You can get the counterweight kit, so you can put a small telescope on it, or a camera with a big lens. So again, that's probably one of the most popular devices there. I had an opportunity to try this unit. Risa Horowitz, one of our members, has the Ioptron Sky Tracker. It's a little bit bulkier than the Vixen Polaria, but you can see it has an integrated base, so it's easy to hook up to a tripod, easy to get the latitude angle to begin your polar alignment. It's got a sort of a classic polar scope in it there. So the manual, poorly written as usual, but I waded through that and I was able to get it to work without too much effort and got satisfactory results with that. So again, this is a really hot area. This is one of the newest units that I've seen, the Fornax unit. I don't know anybody that has one of these. All of these commercial tracker, Star Tracker units are in the $300, $400, $500 range, which is about the price you would pay for a lightweight equatorial mount. So again, I was sort of really sitting on the fence. I didn't want to spend a lot of money necessarily on one of these. I was just sort of looking at what was going on in the field. And I have this. I have the classic Vixen Super Polaris mount. And that's a lightweight equatorial mount. It's very highly regarded. It's nice and smooth. I have hacked mine, so I've got motors on it. I can track. I can do go-to on it. So you could do, I could not put my telescope on that, just hook my camera up to it, and I've got the same sort of solution. So I thought, well, I'll just use my Vixen Super Polaris to do wide field imaging. It has decent payload capacity, except now if I'm using it, I don't have my telescope in operation. So it was on talking with Ian Wheelband, it's all his fault, that he and I started talking about this in some detail, and he told me he had built one. So I was intrigued by that. He had based his on Gary Serenek's design. So if you look up Barn Door Tracker, Gary Serenek, you'll find his design, all his plans and stuff. So wood plates, hinges back here, motor, so it's hands-free, all the gearing and stuff. There's a curved rod, a little bit hard to see. You can just make out the curved rod underneath there. Gary added a little finder scope to it to help get to polar alignment. You may need a ball head. I didn't have one, so I had to get one of those to make all this work. But it's a nice design. Ian showed me that website, so I sort of checked it out. And Ian brought his Barn Door Tracker that he had built to the Algonquin Radio Observatory. A bunch of us went up there, so I had an opportunity to try it out. The skies weren't great, but I was able to do a bit of long exposure tracking with it. Then he told me he had the parts, that with another astronomy group, a bunch of the members had decided to build Barn Door Trackers. So somebody organized all the parts, got all the gears, made the curved rods, got a bunch of the electronics. They put these kits together that members could buy. And Ian said, I've got all the parts to make a kit. So I bought one of those kits from him when I decided to finally pull the trigger on this. Ian sent over his electronic diagram, slightly different from Gary's. Ian had added an external power supply, so he wanted to protect the voltage regulator. He put some diodes on it. This was sort of illuminating for me because I've been teaching myself component electronics, so I looked at the circuit and I understood it. I knew what was going on, knew that it would be easy to build that. So again, the bug bit, I decided to go ahead and do this because I have the tools. I might have some of the talent. I like the idea of a compact solution that runs on just a battery, so a regular battery that's hands-free, that could be tracking the sky with my camera while I'm doing stuff with my telescope. I like the idea of multitasking. I like the scope of this project. It's small. I'm not an ATMer. Clay, I admire you. I'm not. Maybe one day I'll build a telescope, but there's no way I'm going to grind a mirror. There's no way I'm going to do that. I do not have. I'm just going to buy the focuser. I'll buy the mirror, and maybe I'll make the wood bits of it. But I like this because it was small. You know, a small project, something I could do on rainy days, and I assumed it would be fun and rewarding and stuff like that. So, lots of reasons. Sort of a lot of things came together for me to decide to go ahead to do this. So September 2014, I start working on this project. I get the kit from Ian. I don't know if you can see all the bits and bobs in there, but that's a lot of the things that would be needed to make it work. There's the hinges. There's some electronics. You can see a capacitor in there, the voltage regulator, the rheostat or the pot for changing the speed of it. The gear, the rod was already curved. Yay, I didn't have to do that. There's the motor. So I had the kit. There were a few pieces missing, so I had to add to that. So I prototyped it. I put all the bits together and tested it and found right away a problem. I didn't notice it at first. The motor here has a battery pack attached, and that's a single cell. That's a C cell or a D cell battery pack. Single battery. And Gary's design called for a 3-volt motor. This was a 1.5 volt motor. So right away I saw when I did my prototyping, the motor's spinning way too fast. It's twice as fast as what it should be. So I start sort of thinking about that. How do I solve that? How do I adapt it? I also wanted a power indicator. I wanted to be able to see when I had the unit on. I don't know if you could see it in there, but there's a little red LED indicator. So because you always forget to turn these off at night. So I designed my own circuit. Well, I modified Gary's circuit here. So it runs on a 9-volt battery. There's my power indicator LED. I kept Ian's diodes in there to protect the voltage regulator if I want to hook up an external power supply. There, R2 is the variable resistor to increase or decrease the speed. 1.5 volt motor, I kept it. I could have changed the voltage regulator or the motor. I didn't want to do that. I just wanted to keep all the parts that I had. And I knew I had learned enough about electronics while it's crude that I could do voltage dividing. So the resistors here at the end take care of that. I got the voltage at the proper level. This was a really satisfying part of the project because for me, I hit a threshold. I was able to start to build or design my own circuit. So I was really happy with that. When I prototyped it, it all worked. So I assembled all the parts. I made the circuit board. I made this box, the control unit, and so on. That was sort of silly to do a clear plastic, but I wanted to show it off to people. But this was a frustrating part of the project because I made one mistake when I was soldering, and some of the components actually failed. So it took me a long time to get this working, many nights scratching my head and trying to debug the circuit, but I got it all working. So that was done in December 2014. So I moved to the next step, and that was to get the wood, or at least try to find the wood. I don't know how many hardware stores I went to, and I was not going to buy a 4x8 sheet of plywood to make my little barn door tracker, but I wanted some nice wood. Ian, once again, came to the rescue. He had an extra piece of Baltic birch, so I bought that from him for a few lug tread beers. And if you need stuff from Ian, that's the way to do it, is just hand him a lug tread, and there you go. So with the help of Tony DeSantos' jigsaw, I cut the plates. You can see I varied a bit from Gary Saranick's design. I didn't do the curvy bit here, so I just cheated. Straight cut. And then then later in 2015, I assembled all the pieces. So this is looking from the bottom, and there's the motor, power or data connector, if you will. The upper plate, you can see a bit of the hinge there, and here's the side view. Over the Christmas holidays, I had retrieved an unused or a spare finder from my old Celestron 8-inch SCT telescope. So you can see I put this on here to help me get to Polaris. And behind it, you can see the ball head. So again, I had to purchase a ball head. So not strictly part of the barn door, but that was an expensive element to acquire. But here it was all ready to go. So here's first light. On the 24th of March 2015, I took it to the city observing session at Bayview Village, and can you see the numbers down at the bottom? I have a 55 millimeter lens.
5.6.
Yeah, so 120 seconds, 2-minute exposure, and if you look closely at those stars, that's the bottom of Orion right there, pretty round. So I was happy with that. The first use of it, it looked like it was working pretty good. I was happy with the results, but was learning stuff at the same time. I could not aim up high. The body of the camera was hitting the top plate. So I had an interference or a height elevation problem that I needed to resolve, but I calibrated it, counted the number of teeth on the gears, how long it took for that to go around, did all that. Did another shot, and here I'm at 180 seconds plus, and still pretty round stars, except I bumped the stupid lens, so it knocked it out of focus, but still round stars, so happy with it. It was working. But a challenge that I was experiencing, even at the early stages, was how do I get to Polaris, and how do I know I'm on the North Celestial Pole? So that was in the back of my mind. Took it, put it into real use. I went with Nicole Mortellero up to the Forks on the Credit. Darker skies, obviously, April 2015. Did not a terribly long exposure, but got a nice result with Orion. There, and then I aimed in a slightly different part of the sky, and there's Jupiter beside, you see it? The Messier 45. So again, pretty round stars there, 45-second exposure, happy with that result. So first use of it, I was getting encouraged, things were working right. Took it up to the CAO on June 2015, aimed towards Scorpius. I believe that's Saturn at the time, just above Scorpius right there. And not great focus, but slight trailing as well. But I was trying out a fisheye lens, the Rokinon 8mm fisheye on my Canon 40D, which is the APS-C chip. But once again, a 2-minute exposure and pretty good sort of results there. But I was getting increasingly worried about the issue with respect to polar alignment. And I used that little finder scope right here, and I was wondering, how do I know that that is aligned with that hinge? You know, like the little pen tube. You know, how is it perfectly aligned? I wanted it to be coaxial. And that's a true finder scope. It's not a polar scope. Polar scopes have those nice reticles in them. It tells you where to put Polaris so that you're on the North Celestial Pole. I wasn't using something like that. So I had to figure that out. I just used my software to help me figure out where the North Celestial Pole should be in relation to Polaris. So that's easy to simulate, and I have a chart now that I print out periodically, and I take that into the field. But I was still trying to figure out the axially alignment, and I got it in my head for some reason that if I move the finder scope to the bottom plate where you see it now, this would avoid collisions up top with the camera. I'd have more real estate and so on, but I was still sort of perplexed by that. I continued to look at other people's designs. Here you can see the finder scopes on the bottom, curved rod again, and so on. So I like that design. The top plate, free and clear. I was also worried a bit about weight. You know, how much torque can that motor generate? I don't know exactly. So I just thought I'll reduce the payload on the top as much as possible. So move things down to the bottom. And that yielded version 2. I made a bigger plate to handle the finder scope on the bottom. I did the finishing of the wood. I put labels on the control unit and so on. So again, slowly progressing here through the summer of 2015. Then I considered how to accurately and smoothly and progressively reach the North Celestial Pole. Your equatorial mount has azimuth screws and elevation screws to let you dial in precise polar alignment. So I considered a slow motion control. Orion has these little tiny controls. They're really built for binoculars. They're fairly lightweight, but I knew something like this would work for fine adjustment, so I borrowed one of these to try that out. I considered a geared head. There's the Manfrotto one. Anybody know how much those are? They're like $300 or $400 just by themselves. A pro grade. I didn't want to do that, and somehow it felt out of place as well, something like that under this. I wanted something that was integrated and made with the same stuff, made with the same parts, that would do the altitude and azimuth. So I continued researching things. I stumbled across this design by this person, ZZJ. I don't know who that is. But if you look up, again, Barn Door Tracker ZZJ, you'll find this design. That's not suitable for work, so read that, you know, at home. But there were lots of things that caught my eye. The finder's on the bottom again. There's a little wire rope here to prevent it from snapping opening, and a bearing. I thought, ooh, that's clever. I thought this was a neat idea. Put the little polar aid right on it. That's just a round piece of paper. You could use a CD if you wanted to. And then I saw this. See it? More wood plates, hinge, screws. I went, aha, this has an altitude azimuth adjustment on the bottom. That's the back. Here's the front of it. See the screw, more additional wood plates. This is quite a complex design that this person has built, but there's the altitude screw. I knew I didn't need that much. I needed a degree or so to change the altitude. There's the azimuth screw, but I just liked how it was made out of simple parts again. So that gave me some ideas. So I started designing my own wood plates, and they would just pivot. There's the pivot point at the back, and I would use simple brackets and simple fasteners to push and pull the top plate. Does that make sense? The top plate would move in relation to the bottom plate just by turning this screw. and then in my 3D software, I added a elevation screw. So this is the bottom plate of the barn door tracker. That's the existing plate. And that would allow me to change the elevation a slight amount. Again, I just needed about a degree of motion in both of these axes. And a metal plate here to protect the wood. I did a full mock-up with my existing barn door tracker base with the measurements and saw a collision problem. Oops. So I needed to move the bolt out of the way. I don't know why, but I made the bottom plates quite small. So I resized everything, moved things around a little bit. Now I've got the proper clearance for the altitude screw, but I saw I was getting close to the motor. It's a good thing I made the bottom plate bigger, serendipitous, so I was able to move the motor outboard to avoid collisions with that bottom plate. So I started to get the bits. I needed more hinges, obviously, to do this, and some nuts and bolts and things like that, some L brackets to make all this work. And I sat down a couple of times to sort of assemble things and put it together. I also wanted to reduce the friction between the two pieces of wood, so I thought about that for a while to get some materials. All the while, I started to sort of put this on the back burner. I was getting a bit distracted. I wanted to focus on some other things. So it took a while to actually come up with a solution here. I was stumped for a while. Yeah, it's made of wood. When I cut the tiles and then dry fit everything together, I found a new interference problem, that the pivot point was right where the existing hinges would need to go for the bottom of the barn door tracker. So I didn't know what to do. I continued, though, to use the barn door tracker. It was still functional, no problem with it. 2017, up in cottage country, I used the slow motion control under it and was able to very easily get to a good polar alignment. That's the Pleiades, and you can see a little bit of the nebulosity in that. Again, in not a terribly long exposure, 45 seconds for that. So then February 18, 2018, I sit down, okay, today I'm gonna do it. I'm gonna finish this thing, hell or high water. And was looking at the parts and trying to figure out how to solve it, and then light bulb. I realized if I take my whole Altaz base and flipped it upside down, all the interference problems went away, which if you look carefully at ZZJ's design, he's doing that. So when I turned the Altaz base upside down, it all worked. So I was energized, I put it all together, so here's the front of it. There's the Altaz plates, and there's the pivot point, big bolt through there, and there's the altitude screw, so a simple eye bolt, and that pushes against the bottom plate to increase the elevation. I had moved the finder back to the top for some reason again. Here's the back of it. There's the azimuth screw. That's not the final configuration, but you can see it pushes or pulls on those two angle brackets there. So it all worked. And I've added vinyl tile between to reduce friction between them. So very happy with that. So I took it outside into the backyard, did a test, and I went big, 300 seconds. And that was without a proper polar alignment. Just super, super quick polar alignment, 300 seconds, nearly perfectly around stars in a fast part of the sky. I was near the ecliptic there. So was it worth it? Yeah, kinda. You could see you could build one of these for less than $100. If you already have a ball head, you're good to go. If you've got a lot of these parts in some bins or boxes in the basement, you can do this pretty easily. The Altaz base on the bottom, you don't have to add that. You can build from Gary Cernik's design. He says you can do it for 20 or 40 bucks, but I think you're probably into 100 when you add some of the other bits to it. The time, if you look at the times, these are all kind of screwy here. The barn door tracker proper, working at a casual pace, sort of on weekends and rainy days, I was done in 6 months. But the Altaz base, when you look at that, 2.5 years. So again, I got stymied, but it was a low priority at this stage because the solution was sort of working. there. But overall, I enjoyed it. Lots of kudos and thanks. Lots of people helped me out with this. Obviously, I went to lots of hardware stores, lots of electronic stores. Too bad Active Surplus with the Gorilla is not still around. And I used lots of software. I used Visio for planing purposes and electronics. When I build electronic circuits, I use the free software Express SCH and PCB to help do the circuit design. It's very smart, easy to use software. And I use the old discontinued, I still use the Autodesk 123D for my 3D design, and that helped me avoid some collision problems with it. If you're interested in building your own and you want to do it real simple, just go to Gary's website and follow his plans. It all works. If you want to build one like mine, I have documented everything. I've documented all the steps, all the painful mistakes that I made, all the trips to the hardware store over and over again. But I've documented all the parts that you need, all the supplies, and all the tools. And I can give you those lists if you want to do that. There's a wide field photo. I just love doing stuff like that. I did that when I was down in the US for the eclipse. And that's a 3-minute shot with a fisheye lens. So that's the kind of stuff that you can easily do. So I don't know what my time is like, but thank you. And if we have time for questions, I'll take it. Hi, question way at the back there.
Hi, I have a comment and a question. The comment is a replacement. Is this working?
Yeah.
Oh, good. Can't tell. There's A1 Electronics, which is on North Queen by Sherway Gardens.
Yep, I've gone there. I didn't go there for any of the parts for this project, but I go there for other stuff.
Yeah, I mean, that place is full of junk, more than Active Surplus, and if it ever catches fire, they're going to have to evacuate Etobicoke.
The guy that runs that place, he's a barnacle.
Oh,
he's just a mean person. But if you're on his good side, you ask, where is this kind of capacitor? It's aisle 3, 4th shelf, in the rusty old box. Okay.
Yeah.
He knows where everything is. Sorry.
Yeah, it's a crazy place anyway. My question is that 4 RPM DC motor, because I'm thinking that's really a slow speed for a DC motor with commutators. I assume it's got some segments, whatever. How picky is it on the motors? And like, I'm surprised that a DC motor will run reliably at 4 RPM, but you can comment to that.
For me, it's working well. That's a good point that it's a DC motor. It's not a stepper motor, but it's functioning fine for me in all these trials. I've not had any stalls. It's not going the wrong direction or things like that. So yeah, it's working well. Again, there's some unknown factors. That motor was provided in the kit, so I don't know exactly where it came from and what the specs of it are. I didn't look up any of that information. That was one of the bits that Ian gave me, so I just went ahead and used it. Yeah.
How long does it take you to get started?
So the startup process to do this is pretty quick, all things considered. It's not nearly as involved as obviously a full equatorial mount setup. So I have it on a fairly flimsy tripod here right now, but I usually take a fairly robust, heavy tripod, set that up, roughly aim it to Polaris. The fine tuning of Polaris with the Altaz base now, I think is pretty straightforward because I've got a little chart with me, and I know where Polaris should be, and I know how the finder scope is presenting it. So it's probably 15 minutes of setup, and then I'm ready. Then it's just what I want to do with my camera exposure and all the usual stuff in that respect. But the setting up the barn door itself, 10, 15 minutes. Yeah.
And how long in a night can you go?
So that's a good question, and that all depends on how long you build that curved arm. So the curved rod that's on the bottom here that you can see sticking out, that defines your total run there. So however long that is. Now there's other factors. The the plates will open up so far, but at some point you'll get into a balance issue. So you gotta watch out for that as well. So I suppose you could have a longer arm in it, but you're gonna have to make sure that it's balanced, that it won't flop open at some point. So all these types of devices often have limits like that. The swing arms do, the classic barn door tracker has a limit. I'd have to think about what the total time is for that, but it's maybe a couple of hours. So it's been fine for my purposes so far. I don't know if you've noticed it, but I turned it on, and it's been running the whole time. So it's moved about 5 degrees or so during the whole time. It's opened up as I've done that. So look at the image at the beginning of the video and at the end. And you'll see that it's been moving the whole time. Anything else? Any other questions? I see Clay's got one at the back.
Hey Blake, how do you reset it when you're ready? Say it's reached
Yeah.
the end of its travel.
Yeah.
How do you reset it so you
So
can start all over again?
That's super easy to do. You just lift it up. I've disengaged the motor gear and the small gear. Just spin this guy up to the top till it reaches the top, and then just make it mesh in again. So it's easy to pop it back in there. And it's running again. So you just spin the gear all the way back up to one of the limits again. The system that Gary Saranic designed, or at least that I've used, has a north-south switch on it. So if somebody goes to Australia and you've built that into your barn door tracker, you just remember to flick the switch and you're going the other direction for the southern sky. I've taped the speed control because I've been trying to really carefully calibrate it. It's a multi-turn pot. I forget how many turns it does from end to end, but it's super sensitive. So I keep bumping it, knocking it off a little bit. So that's why I've got it taped down here. Not that it's falling apart, but I just don't want that knob to move anymore. So I've got it in a nearly perfect sidereal motion. Another thing, another little trick that I've learned in all of this is to I was working backwards. I was doing shorter exposures and then longer exposures and longer exposures, kept doing that and looking for trailing in the increasingly longer exposures. But now my workflow is different, and again, this speeds up the time, the setup time as well, that I start with an extremely long exposure. Say I'll do just a 5-minute shot right at the beginning. And with the intention of maybe doing 2-minute or 3-minute exposures. So I'm kind of using double what my planned exposure is. I let it have that first run, and I look for trailing to see if my polar alignment's good and if I need to adjust the speed control a lot. Then I drop it, my exposure back to half, and I have no trailing then. I have round stars at that stage. So that's just a slightly, it sounds counterintuitive, but I think it's a much better workflow to start with a super long test exposure, then go back to the normal exposures. Yeah. Yeah, a couple of questions in the middle there. There's a mic there if you want, right beside you on your right.
Not sure about the use of your altitude adjuster. Are you using that mostly to polar aligned, or are you using it during the shot because it's not motorized?
No, not during the shot. So during setup, I'll be looking for the North Celestial Pole here in Polaris, and then I'll use this to increase the height or decrease the height. And you'll barely be able to see any motion here, but then I use this screw that's at the back to adjust the azimuth now. So as I turn this, it's moving left and right and up and down.
It's just
so this is strictly
adjusting the tripod.
It's strictly for the setup.
Okay. Thank you.
So when I put it on the tripod, I quickly do a rough alignment to 45 degrees up, right? And I'll look for Polaris in here, and that's close enough. Then I'll do fine tuning with those 2 screws like I would on an equatorial mount with the polar axis scope to dial into the North Celestial Pole. Yeah, and then I don't touch those anymore after that. I have found a weight balance issue when I truly have this at 45 degrees, and if I've got my camera quite far back, it wants to flop open. So the simple low bandwidth solution that I'm going to do there is I'm going to put a big rubber band right here. But I could have a fixed fastener there, so I'm pushing or pulling on a nut on that. That would fix it as well, but for now I'm just going to put a heavy-duty rubber band on it, and that will take care of that. There was a question here, yeah. Where'd that mic go? Tom's got it.
2 questions. How did you solve, if you can quickly, how did you solve the coaxial, getting the finder scope on the same axis as the hinge?
So I haven't tested this in the field yet, but I'm convinced it will work. What I was thinking is when I had the finder scope up here, that I would open and close it during setup. I would open and close, and I could do this in the daytime, right? Aim to a hydropole a couple of kilometers away. And as I opened and closed, I should see on the crosshairs in the finder that the hydropole stays right where it should be. So then I would know that this is coaxially aligned with this hinge. But the technique, see if I can remember it here, the technique that I read somewhere on the interwebs was to just crudely aim to Polaris, aim the camera towards Polaris, and just do it with the camera. Essentially the same thing with the camera, and dial out any motion that way, and then it's good to go. I'm missing a step or two there, but I found that procedure, and it sounds like it will work perfectly. So I had tried to do it on the top plate here, and I wasn't satisfied with the results. So I've got this new procedure that I'm going to use, and it should work fine.
And one other question. If I want to avoid using, I don't know if you can be able to answer this, but if I want to avoid using the curved rod, is there a way? Have you thought about anything way to?
So there's a lot of interesting designs for barn door trackers, a number of which that don't use curved rods. There's something called the dual arm. So this is a single plate, but a richer design is that there's another plate that's going this way, and the rod pushes the second plate, and that's doing something trigonometrically to compensate for that. So the dual arm design uses straight rods. You've got 2 things that are pushing up the camera, and that also is quite accurate. Lots of people now are using Arduino and have variable rates on the motor. So straight rod, and you program a variable rate, right? Hire these guys to do it. Would you help us with that? You're all crackerjack with Arduino stuff, so that's another way to do it too, just with code, right? So there's a lot of solutions to avoid the curved rod. The curved rod thing is pretty straightforward, though. You just get an old piece of furniture, not something in the dining room, but a nice round table, and bend the rod around a nice big round table. So there you go.
Okay, ladies and gentlemen, Blake, thank you very much.
Thank you.
All right, and now we're going to just wrap things up with a few announcements from our president, Ralph. While we're setting up here, just one quick announcement from the library committee, aka me. We're looking to fill some gaps in our magazine collection, and if you've got a large number of back issues of Astronomy or Sky and Telescope, this is your chance to unload the lot. To make things simpler for you and for us, we'll take the whole thing. One-time deal only. We're going to post the full details on the forum in the coming days. But if you're looking to get rid of stuff going back, a decade or more, come talk to me.
Okay, well, we're just setting up for the announcements there. A couple of other notes. As you know, tonight there was another event going on at the Science Center, which is why we had that flurry of announcements about getting your membership card and all of those things. But the display that goes along with the special Great Conversations program tonight is open until 10 o'clock. And since you're already in the building, Rachel has indicated that you're welcome to go through the exhibit if you like before you leave tonight. Also, apparently there's the Gorilla Shop, which is run by somebody formerly associated with Active Surplus, that is open in the display as well. So so you can go rating their surplus stock. So that's a couple of interesting things to go with it. Okay, so tonight we'll just take a look very briefly at some of the things coming up over the next 4 weeks or so. Our next meeting is on Wednesday, the 18th of July, and Andy Beaton will be doing the Sky this month for that meeting. Frank Dempsey will be talking about Oumuamua and implications for the origin of life on Earth. And Paul Markov tells me that he's got 1 or 2 slots that he can still keep open for that evening. So if anybody would like to do a presentation that evening, please contact Paul. He'll be happy to slot you in. We've got a lot going on over the next few days in terms of outreach. For example, on Saturday morning, we have the regular monthly solar observing session out on the Telescape, and Sean is the coordinator for that, and he'll be doing the usual announcements on the forum as well as on the website and on Twitter and so on as far as a go, no-go. And hopefully the weather will cooperate. But it's sort of dicey right now because the last forecast I looked at was sort of, it had clouds and thunderbolts for Saturday and Sunday. So we may be holding it over until our backup date, which is actually on July 7th, which also has something going on. So we've got a bit of a conflict there. Maybe it'll be cloudy down here too. Anyway, we'll see what happens. But anyway, that's one of our events that's going on. The other 2 regular observing events that we have coming up, well, we've still got one more night for City Star Party this week, so hopefully that'll be tomorrow night at Bayview Village Park. But the next one of those events after June will be the first clear night of the 16th through 19th of July. And the week before that, we have the Dark Sky Star Party, first clear night of the 8th through the 12th of July at Long Sault. So again, in the usual way, we'll have go or no-go calls on the forum, on the website, and so on. This coming Friday night, we have our Millennium Square Stargazing Night between 6 and 11 p.m. Out in Pickering. And again, there will be a go or no-go put onto the website. So if you're out in the East End and want to help out with that, please go ahead. At the same time, this weekend, we've got a couple of things going on. For example, here at the Science Center on Saturday night, from 7 till 11, we have the Shoot the Moon Star Party. And there's a lot of really interesting presentations going on that evening, and those are on the website, so you can take a look at that. At the same time, we have another event going on at the DDO, at the David Dunlap Observatory in Richmond Hill. That is a sold-out event again, and we do have a number of volunteers who have already confirmed that they'll be helping out there, so we really don't need any more helpers up in DDO, but we'll certainly need help down here for the Shoot the Moon event. And again, the event has the information on the website. The following week, 28th of June to the 3rd of July, is the annual General Assembly in Calgary. And I think registration is actually going to be closing very soon for that. But that's our annual get-together for the National organization where you can meet members from all over the country who belong to the society. And this will be the last of the General Assemblies that will be organized by a center on its own. Starting next year, the National Society, National Office staff will be organizing a lot of the meeting. And so, again, it's sort of a historical thing that's happening. The other thing that's associated with the General Assembly is that there will be an announcement of a commemorative postal stamp that will be unveiled at the General Assembly. And it marks the 150th anniversary of the RASC. So there's the postage stamp to watch out for. In addition, next Tuesday, there is something that's been mentioned on the forum, and that is the unveiling of a commemorative coin by the Royal Canadian Mint. And that too will be a major event in Toronto. If you have the time and inclination, you can actually participate in that event. It's at 9:45 in the morning at a location in downtown Toronto. And as soon as that event ends, the 5,500 coins that are available from the Mint will be available for sale on the Mint's website. So get them while they're hot. The interesting thing about that is that part of the design, it incorporates a piece of a meteorite in the coin. So a really special thing to mark the 150th anniversary of our organization. I don't know any of the details, but again, so we've got 2 Crown agencies that are doing something to mark the 150th of the RASC. So that's really quite something. Okay. The other big event that's going on will be on the 7th of July in the afternoon is the 20th anniversary CAO Annual Open House and Awards Picnic. And again, this is a major thing that we do have 20 years on the site to celebrate. We've got lots of things that are going on, as you can see. For the barbecue, you know, not only do you bring something for the barbecue, but also if you can bring something for the potluck table, a salad or dessert or whatever, or drinks, that would be great, although the center will be supplying snacks and drinks for the event. The big event, we have a guest speaker this year, Sarah Seeger from MIT, who will be doing a special talk on her involvement with the TESS probe and exoplanets. So that's another major thing going on. So let's hope that actually we do have the solar observing on the weekend, so that Sean can come up too. Okay. Finally, also just a reminder that the Carr Observatory is available for your use. All you have to do is book online, and this is the busy time of the year, so you definitely do need to book. If you're going in on the weekend, you'll be able to use the new telescope in the GBO when the supervisor's on site. Otherwise, plenty of other things that you can use as well. And also remember that the Telescope Loan Program makes available a large number of instruments for you to borrow, to try out before you buy. So it's something else to look at. Okay, and oh yes, as far as the Telescope Loaners Program is concerned, we do have the managers up in the audience tonight, so they'll be here to talk with you if you're interested. Okay, and we'll just wrap it up by saying again, as usual, if you'd like to join a few of us at the Granite Brew Pub down at Mount Pleasant in Eglinton, we're going there after the meeting for a bite to eat and a bit of a drink. And we'll see you there, hopefully. And have a good time over the next 4 weeks. We'll see you at some of those events. Have a safe trip home.
Just a reminder, folks, the card for Don Austin is up at the front. If you'd please sign. Thank you.